In Chapter 3, we're going to start studying what's referred to as stoichiometry, and we're going to learn that as the coefficients and the ratios that are involved with balancing chemical equations. And then once we have stoichiometry down, we can start to do some calculations that involve those coefficients. So let's look at the general form of a chemical equation. And what's first defined here as the law of conservation of mass. So we are going to keep this in mind when we do our calculations, that atoms are not going to be created nor destroyed during a chemical reaction. So mass is conserved. So we can think of that as if we weighed all of our reactants, which are on the left-hand side of a chemical equation, they would weigh the same as the products. They are different compounds on the reactant and product side, but the amount or the mass of both the reactants and products would be equal. So down here is just a general form of a chemical equation first. So we have in this row here, two hydrogen molecules combined with one oxygen molecule, and our product is two water molecules. So we see that 2 is the coefficient for H2, and we could see 1, 2 if we have the ball and stick models shown here of two hydrogen molecules, and then we have just 1. So there's no coefficient shown when it's just 1, like so with oxygen with O2 here. And now we have 1, 2 molecules of water. So we know water is 2 hydrogens. So there's 1, 2 on each of these water molecules, and then just a single oxygen in the middle. So again, this is the general form of a chemical equation, and this represents the amounts, the stoichiometric coefficients that are involved with a balanced chemical reaction. And we could write it unbalanced. We'll see a little later on, and then we can solve to figure out what those coefficients are. The states of our reactants are generally written in parentheses on each side, or to the left, rather, of our compound. So we can see that down here in this reaction of methane with 2 moles of oxygen. So that's what that 2 implies there. We have the state. So these are all gaseous state, both the reactants and then both the products over here. The coefficients that I mentioned, those are the numbers out front, and they tell us what the ratio is of each of the reactants when they combine. So I have 1 mole of methane here, so CH4, to 2 moles of oxygen, and then when they react, they produce 1 mole of carbon dioxide and 2 moles of water vapor. So the subscripts that we looked at before, they tell us the number of atoms within the molecule. So a subscript is down here. So there's 2 hydrogens in each water molecule. And then the coefficients, that tells us the number of molecules. So we have 2 moles of water here, and water itself has 2 hydrogen atoms. So if we were to break down into the individual elemental pieces here, we could see over on our reactant side, we have methane, which is 1 carbon and 4 hydrogens. And then we have 2 moles of O2, so we have 4 oxygen atoms. And then when we balance a chemical reaction, we want to make sure that we have the same numbers on the product side as the reactant side. So I see 1 carbon atom. I see 4 hydrogens. So 2 moles of water times 2 gives us the 4 hydrogens that we're looking for. And then I have 2 times 1 oxygen plus 2 more gives me the 4 oxygens. So I can tell that this is a balanced equation, chemical equation, for the combustion of methane gas with oxygen, and the products are carbon dioxide and water. So if we change coefficients, we change the compound. I'm sorry, if we change coefficients, we change the quantity. So this means that we have 2 moles of water. But if I went down here and instead of putting a 2 out in front, I put a 2 after the oxygen, this changes the identity of the compound. So this is now H2O2 instead of H2O. And this is what we call hydrogen peroxide. So there's 1 hydrogen per each oxygen. So never change the subscripts when you're balancing. So only change the coefficients. So let's see if we can do sample exercise 1 here, and we'll figure out how many atoms of magnesium, oxygen, and hydrogen are represented in this notation here. So we have 3 out in front, that's our coefficient. We have 3 moles of magnesium hydroxide. So within this molecule, I have, if we were to just break down MgOH2, I have 1 magnesium 2 plus, and I have 2 hydroxides, which are OH negative. So I have 1 of these, 2 of these, and then I have 3 as my coefficient. So I'm going to multiply 3 times 1, and I have 3 magnesium ions, and I would know that I would have 6 hydroxide ions contained. And then if I wanted to know how many individual atoms, I know that for every hydroxide, I have 6 oxygen and 6 hydrogen. So my final count is going to be 3 magnesium, 6 oxygen, 6 hydrogen for this problem.